Today we will determine and identify triangle congruence by side, 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 and side angle side using notes and worksheet. The new vocabulary that you're going to learn is included, which is a side or angle that is between two sides and angles. The reflexive property is a line that is shared by two figures and is congruent to itself. And we'll show you more examples of that. A midpoint. You've seen this before, a point that splits a segment into two congruent segments. Vertical angles, a pair of angles that are opposite each other when two lines intersect. And congruent means a pair of figures that has the same size and shape. Are the two figures congruent, and why? So what we should do is figure out if the corresponding parts are congruent. X is corresponding to M, Z is corresponding to L, Y is corresponding to N. They all look to be the same. So yeah, what is the congruency statement? We should say that X, Y, Z is congruent to M, N, L. Are the two figures congruent? Well, AB is corresponding to XY, BC is corresponding to YZ, and ZX is corresponding to CA. So the two triangles are congruent. The side, side, side theorem says that if three sides of one triangle are congruent to three sides of another, like here, 1, 2, 3 sides are congruent, then the triangles are congruent. Examples. Here I know that three sides of this triangle are congruent to three sides here, so they're congruent. These I only know that one side is congruent, so it's not side, side, side. Here I know I have two sides that are congruent, and I know that M is the midpoint, which means it splits this segment into two equal segments. So I have three sides congruent. Here I only have, well, I just have one. Here I have 1, 2, 1, 2, and they share this one, so that's my third. Here I just have 2. Can you conclude the two triangles are congruent by side, side, side? This side and this side, this side and this side, this side and this side. The answer is yes. Here, can you conclude two triangles congruent by side, side, side? This side and this side. This side is the same as the other side, so it's an isosceles. And here, they're the same. So the answer is yes. Can you conclude the two triangles congruent by side, side, side? Here and here. Here and, well, I don't have a second side, and I have this and that. So I only have two sides that are congruent, so these are not congruent. Let's see, 3 and 3, 4 and 3, 5 and 5. So these are not congruent by side, side, side. Are the two figures congruent, and why? They sure do look the same. I have a side here, I have an angle here, and I have a side here, which means I have three parts that are congruent, but I don't have three sides. Let's look more into that. See how I have a side, an angle, and a side? This is the SAS theorem. It says that if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. Which means, included means I have a side and I have another side. If I have an angle in between these two sides, it's called an included angle. Here I have a side, an angle that's included in between these two sides. So I have side, angle, side. And you'll notice that this A is in between these two S's. So this A is included in between these two S's. So let's try it out. I have a side, 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 side. So these triangles are congruent by SSS. And let's talk about this side, this angle, and this side. Does that work out? That does work out. Okay. So it could be SAS as well. Here I have side, side. I have vertical angles here, so that's angle. And I have S here, side. So that's SAS. Let's try this one. S, 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 S. And I have a side that shares, right? This is the reflexive property we're talking about. If they share a side, we're basically looking at the same triangle, just a reflection of it, right? So this triangle right here has a reflection that goes on the other side, which means they share the same side, which means I have SSS. Are the triangles congruent? Let's see. I know nothing about the sides, all I know is about the angles. But they don't look the same, do they? So, angle, angle, angle. If three angles of a triangle are congruent to the three angles of another triangle, then there is not enough information to determine congruency. So if all I know is the three angles, then I don't have enough to tell me that these two triangles are congruent. Let's look at here. JM is equal to PR, so that's a side. MK is congruent to RQ, so that's a side. What additional information do we need to prove the two sides congruent by SSS? So that means we need a third side. I'm thinking JK should be equal to PQ. Given AC is equal to CE and DC is equal to CB, what additional information is needed in order to prove the two triangles are congruent? Well, I know that I have two sides that are congruent, this one and this one, and this one and this one. I know I have two angles that are congruent because they are vertical angles right here, which means I have SAS. That's all.